I'll be looking here at question 7 of the National 5 2015 physics paper, and it's a question about forces. So we're told that there's a ship of a certain mass, 5 times 10 to the 6 kilograms, and there are two forces acting on the ship. One force is this 8 times 10 to the 3 Newton force, that's the engine force, and the other force is the force applied by the tugboat of 6 times 10 to the 3 newtons. You'll notice that they're at right angles to each other, and so it's probably going to be a question about finding the resultant of two forces at right angles to each other. So if we look down, we can see that that's exactly what is the case. It says, by scale drawing or otherwise determine the size of the resultant forces acting on the ship. So that's what we're going to do right now. We'll do it first of all by the otherwise method, and then we'll have a look at the scale drawing afterwards. So by otherwise would be using Pythagoras. And Pythagoras means a squared plus b squared equals c squared. And so what we've got here is that, oops, I've clearly got a wee bit of a mistake here, so I'm just going to add in that it's the resultant squared is equal to the vector 6 times 10 to the 3 squared plus 8 times 10 to the 3 squared. And so if you do that sum, you get your resultant to be 10 times 10 to the 3, or 10,000 newtons. And in my mind, that's probably the simplest method of doing this problem. You're just looking for adding the two vectors by Pythagoras, and that's how you would do it. So the second method is by scale drawing, and I would imagine most people wouldn't do it by scale drawing, but this is what you might draw if you were drawing it by scale drawing. The top arrow would be the 8 times 10 to the 3 Newton force, and the this downward arrow would be the 6 times 10 to the 3 Newton force. Now you'll notice that I've drawn these two vectors tip to tail, or nose to tail sometimes they're called, and so that's the correct way of drawing them, showing us that the blue arrow represents the resultant force. And that's fine, that's great. If you do it that way and you draw it accurately, maybe that's 8 centimeters along, that's 6 centimeters down, you'll find that this is 10 centimeters, and therefore your resultant is 10 times 10 to the 3 newtons. And that's great. However, I have seen it done like this. So what people do is they draw the 8 Newton vector along like that, and that's great because as we look up, that's exactly what we've got here, our 8 Newton vector. But there's this downward arrow as well, so what we'll do is we'll draw the downward arrow in, and so that is drawn like that. And so it looks like you've got two vectors that are drawn correctly. The downward one, the 6, and the one that's going to the right, the 8. And so your resultant force is going to be in some shape or form the connection of these two. Maybe it's that way, or it could be the other way as well, this way here. Now you'll notice that the problem with that is that the arrow is not drawn in the right way. The resultant is diagonally up or diagonally down, and it's clearly not looking like this at all. And so if you do that, that's a complete mistake, it's an error. And even if you were to go on to correctly measure the value of the resultant force, you would only get a maximum of 1 mark for that. So it's very important when you draw vector diagrams that you make sure you draw them tip to tail.